Happy Friday. How's it going, everybody?
Hi, everyone.
Don't get too excited here.
Welcome, Gleb.
TGIF. Cool. Well, on today's show, we have Gleb Mezhanskiy from Datafold. For people who don't know who you are, do you want to give a quick intro?
Yeah, absolutely. I'm Gleb. I'm CEO and co-founder of Datafold. Datafold is a data quality platform for analytics engineers. Before Datafold, I was a data engineer at companies including Autodesk, Lyft, where I was one of the first data hires, and then a seed stage company called Phantom Auto, building remote control for autonomous vehicles. So got to touch the data at very different companies at very different stages, which gave me a very interesting perspective on, I think, what are the common denominators, but also different things that you need at different stages.
That's really cool. What are some of those common denominators?
I think the common denominator is that it's very hard to actually apply data to business, whatever, at whatever stage you are. And some reasons are similar and some reasons are different. I think at the smaller companies, it comes down to resources, both in terms of your ability to buy tools, but luckily that's not longer a problem with all the kind of pay-per-use model and modern data stack being much more accessible today. And so mostly comes down to resources in terms of people. So how do you go about doing analytics and automation with very few people that you have on the team, or maybe not even having a data team? Whereas I think at a very large companies, public companies, you have different problems of applying data. It suddenly gets very political, and even choosing what kind of metrics you use and how you go about translating what business asks of a data team to actual data and then communicating that back and telling a story suddenly gets more dimensionality, including what kind of exec you want to make happy, or how do you actually use proper metrics and not vanity metrics that always go up. So these are probably the people problems. But I think the other observation is that data quality is always hard. And I think there's also kind of we can assume that it's big companies or big tech companies that really suffer from bad data quality because, well, they have so much data. But ultimately, this is a problem which you encounter the very first day you put together a data stack, because you start thinking, okay, so how do I know how many users actually sign up for the product? Well, do we have this source? Or, we probably have two sources, then you need to glue them. None of them is perfect. So from the very first day you actually start working on data, you start encountering these issues. And that's why I'm most excited about working on what I'm working, because I feel like solving data quality helps everyone, not just, big tech companies. But it's what always frustrated me is that working in the industry is that I saw, the top data teams at companies like Airbnb, Uber, Lyft, where I worked, who invested so much in data tools. Many of them have data tools team larger than the majority of teams for actual modern data stack vendors. And so that tooling is amazing, and they write, really cool blog posts about that, but it's never really been something that, like a startup could use. So the moment I went from Lyft to a seed stage startup, more those tools were not accessible to me. So that's why I like the idea, not the idea, but what happens in the modern data stack is that a lot of the tooling that a lot of people from these big tech companies are now building tools and offering them at much lower pricing points, and sometimes even offering them as open source. So the bar to actually build a really solid stack and focus on solving the business problem as opposed to solving infrastructure or data quality becomes much lower. So that's my long answer to your question about what I saw through my career.
So let me ask you a follow-up about managing data quality. So let's go back to this example of, like, you're trying to track how many users you have, and you have to combine between two or more sources. And then let's throw in a complication that often comes up in an organization. So say you have multiple parts of the company that define active users in different ways. So active users, maybe someone who's been on the site within the last 90 days, maybe it's a year for a different part. How do we use technology to try to reconcile those kinds of human issues? Or is that something that we can do?
Well, I think technology can assist in reconciling, but ultimately it's down to humans to actually collaborate. I think multiple source of truth problem also appears really fast as you start working with data. So you build your stack, and then someone else is excited. Well, this set of tools is not great. Let's bring a product analytics tool like Amplitude. And now you have the same story, but told by two different tools, or you have different data sources. I think there's no way around it. I think forcing centralization is probably has some really bad side effects as well, because you start slowing down. And these days, there is no single tool, a single stack that really answers all the questions. So I think it all comes down to just really agreeing on, for each question, what is the ultimate question we're trying to answer. For example, if you try to answer how many orders did we ship, and you have to be really correct about this, you might go into one tool and one particular source. But if you're trying to answer a question, where do people fall off in the checkout funnel? Maybe you don't need to know actual numbers. Maybe being approximate here is just fine. What you need to know is conversion rates, and maybe run an experiment and see how that experiment affects, a conversion rate at a particular step. And so maybe you're okay with your whatever the source of this data is actually not being perfect. And I think the worst conflicts that I've seen is when people had the idea that they should have very accurate data everywhere, or use data which is not really meant to be very accurate, like event data, to run something like compliance reports, or some workflows where accuracy is really important. I think it's all about knowing what to expect of your data and what do you want from it, and then designing your products with those expectations in mind. Just not try to conflate a lot of things at once.
Yeah, it's always a question I would ask people when they ask for reports. It's like, what are you going to do with this? Like, what action are you going to take, right? Oftentimes it's like, I don't know. I just want the data. And then, like, can you come back when you have an answer? Thank you. So, and you see this a lot with real time too. People want data quicker, but my answer is, well, if you get this, say hypothetically, if you get this every nanosecond, your report's updated every now, like, what are you going to do differently that you wouldn't be able to do every minute, say? So it's
you'll enjoy it as an artwork on your.
It is artwork. It'd be kind of a cool NFT. We should. It's a new business we should do. Just charts as NFTs.
Yeah, look at based on O'Reilly books in real-time data or something.
Anyway, so
you heard it here first.
Cool. So I think we want to talk about. You sent me this article here. I should share it real quick from the DBT Roundup. Something that Tristan had written, talking about interfaces and breaking stuff. And I think kind of what I was reading into this, and I'd love your take, both of you, is what I read into this is ways to improve the modern data stack. I think it's the impression that I get when I talk to everybody in the industry is it feels like data is it takes a lot of inspiration from software engineering and practices that have already been done there. And we're still pretty early in the data world, and we're starting to incorporate those things in. And I think Tristan's article is a good example of this, where I think he correctly brings up some great points. And so let's talk about that. What was on your mind, Gleb, when you sent this over to me?
So I think the first thing that crossed my mind, which is personal, is that it's great to see, a founder that you really admire who built a tool which is really foundational to basically call to action for a product that I've spent 2 years building. But if we put this agenda aside, I think what really is exciting is that we start seeing and really diving into the complexity of the problem of data quality. It's a really large problem. And I think that it became more acute in the last 2 years, in a way, thanks to DBT and thanks to really foundational modern data stack companies like Snowflake, Databricks, Fivetran, that solved all the infrastructure problems. And now that enable people to build fast. And the faster you build, the more things will break. So we're naturally now talking about data quality as probably the most acute problem out there. And I think what has been happening over the last 2 years is there were a lot of questions, how we improve data quality, what do we need? And there were, a few mainstream ideas around, well, if data breaks and it breaks silently, that's a big problem because, well, we don't want to learn from our stakeholders that something broke. So naturally, there were lots of solutions emerging both internally and in vendors focused on data monitoring. So for example, I worked on this problem at Lyft. One of the products that I shipped as a data PM was a tool a platform actually that was enabled anyone to define metrics based on streaming. So you could take events, monitor them on using basically time series machine learning models, and get notified when this data wasn't behaving as normal. And so that's a very natural reaction to the problem. Well, everything is breaking, right? But as this space matures and as we, start implementing the solutions, I think if you look deeper, you start seeing that, well, maybe it makes sense to start catching certain issues way, way earlier and not focus on production as much. And in software, they figured this out a while ago. And in the site reliability engineering and DevOps practice, there's this concept of shifts left, which basically is talks about, well, ideally, you should catch stuff in production, right? If something breaks, you need to know about this and no questions asked, right? But how can we catch things sooner? Can we catch them maybe before they get to production in staging, or in the pull request process, right? Or maybe when the engineer develops things, or maybe we can catch them in the IDE as I'm typing code and I'm seeing those errors. And I think a lot of software and a lot of ideas have been really implemented in the software developer practice. And especially, at companies that, in big tech companies where they have, they're running microservices, which is a very hard problem because you're changing things all the time and things breaking all the time. But what I was really excited about in this article that Tristan wrote is that we're finally starting to talk about this shift left in the data world.
Yep.
And we're shifting the mainstream conversation about, well, how do we detect things that are breaking, and sort of like accepting the status quo is that things are breaking all the time, to actually how can we prevent things from breaking, and what can we improve in our workflow so that we don't introduce bugs in the first place. And I think there's a lot of potential there, both in the emerging conversation around data contracts, and when we talk about things like data mesh and how do we make the decentralized data reliable, right? We talk about data contracts and how all the systems communicate, but also even without defining those contracts, just how can we improve the workflow itself of analytics engineers and data engineers so that we help them catch things very early in the process.
Yeah, it really, so on the one hand, there's a lot that we can learn from the software engineering world, just as Tristan said. On the other hand, one point I would make is that a lot of the tools are already there. So in other words, back in like the kind of big data MapReduce days, it was the Wild West. And in many cases, there weren't even schemas, right? It was like you would write some crazy job and you would look at the raw data to try to guess what your code was supposed to do, and then you would try it out. And now, at least in cloud data warehouses and meta stores, we have schemas present if we would use them. Like, that's a good starting point. He makes this point too. Like, you can run schema checks before upgrading code, for example.
Well, this actually exists in a lot of legacy tools.
It does.
Going
That's
back
a
to
good
the 2000s,
point. Yeah.
right? But these are all monoliths. These are the expensive, super enterprisey, super expensive things. But I've seen this before, where any changes you make in your your schema or whatever definition, it propagates. It does all the tests to make sure it's going to affect down. But that assumes you have a monolith, right? As I sometimes joke, entropy also means everything becomes Informatica at some point. So like, it's just sort of the natural de-evolution of everything.
Maybe it's gravity. It just sort of coalesces into Informatica.
But there's something to be said for that, though, right? I mean, but in lieu of that, this like integration testing or regression testing is also something that I think we need to think a lot more about as an industry, because again, these practices have existed for a long time in software and with great results. Because I think we're taking baby steps. Obviously, data quality tests are excellent. That's equivalent of unit tests. But again, there's a lot of interdependencies, and especially with the ecosystem as fragmented as it is with the modern data stack, it's how this works, I think is I think open for discussion, but it's a much needed discussion that we have to have.
What do you think about his concept of model versioning? So not every company that does microservices does this, but a lot will just have API versions. And so you don't really have to, you can upgrade your API for your microservice because any other microservice can call the old version until it's ready to upgrade. So it sounds like that's what he was talking about in the data space too.
I think the applying software concepts to data is a very fruitful endeavor, but it also is quite a challenging one because things don't map quite one to one.
Yep.
And I think one of the fundamental differences between the world of software to the world of data is that in software, a lot of things are very deterministic. And so you can unit test them. And they're also deterministic on the user experience, right? So if something breaks for the user, you know it's broken.
Yep.
And you know the moment it's actually fixed, right? It just starts working. Whereas in the world of data, it's very often hard to tell whether a certain number or data set or column is actually giving you a correct representation of reality or not. And that makes the whole notion of quality testing very hard. And a lot of the times we need to kind of give up the idea of like, what is the correct thing versus just making sure we know how we change things. And so to the idea of kind of versioning microservices, versioning APIs, I think the idea of data contracts is a very powerful one, and we definitely need better interfaces between systems. And I think we're start seeing that and different layers of the stack, right? So for example, in DBT, you have the schema and you can define how your models interface. And there's a lot of kind of vertically integrated things that make this whole pipeline of transformations more robust, from defining schemas to defining tests and expectations and running everything together. Also in systems like Dagster, so kind of new generation orchestrators, we start seeing these ideas of software defined data apps. Mm-hmm. And it's kind of a lot of fancy words, but ultimately the coolest thing about this is when you do anything with data, let's say transform a data set in SQL or in Python in data frame, you define what are the inputs and what are the outputs so that whoever consumes this from you knows what to expect. And whenever you change something, you know ahead of time when things are breaking. And this is a very big shift, kind of akin to what Matt's been talking about with the versioning. We haven't had this before in the orchestrator layer. For example, in Airflow, there was no concept of kind of data dependency. There was only a concept of, well, did the task run? If it ran, it's probably okay. But whatever was the output of this task, the tool didn't know. And so that opened up for room for a huge long tail of different things that could go wrong. And so I think we start seeing that. Also in the event layer, for example, tools like Avo or Reflect help you kind of really evolve the event schema and then sync it back to DBT in a very, more robust way than we used to, like maintaining. I'm still remember my days of maintaining event schemas in Google Spreadsheets, which obviously is a bad way to go about this. I think where the contracts and microservices are really currently hitting the ceiling is that in the data world is that what about the cross data stack contracts, right? So we are seeing very few instances where we would have one system handing off data to another system using some sort of a defined contract, let alone having a universal language for those contracts, right? So a lot of the times we would have a one vendor responsible for piping data from Salesforce into the warehouse, and then the warehouse is another vendor. And they don't really talk in anything but SQL or moving data sets. Then you have another vendor, transforming data sets, and then yet another vendor taking those data sets and then publishing them as dashboards. And there is no common interface across all of them. And frankly speaking, I'm not sure there will be, just because data stack currently, to your point, Joe, about entropy is kind of moving in increasing, chaos. But maybe there will be some interface at some point. So I think it may or may not play out like it did in microservices. But even though we might not have contracts, I think we still can do much better with not breaking things if we really harden the change management and do this in a kind of the CI/CD fashion. I think what Tristan was alluding to in the basically checking things before we promote them to prod.
Yeah, there might be a couple of solutions to this too, or at least some, I think, beginnings, like Snowflake's applications. As you get native applications for Snowflake now, that might be a way of doing stuff. So they kind of have an app store and it just works, and that's sort of get the end product of that. But that doesn't account for sort of the tying everything together problem, which is kind of gnarly. So unless you have standardizations, for example, it's, I don't know, it's kind of hard. What, do you have any ideas how we would solve this problem in the next 5 seconds?
Well, no, I'm kind of coming from the opposite side. I mean, the classic problem you run into with an issue like this is, okay, you've identified a problem and we need standard interfaces, but who owns the interface?
Yep.
Is it going to be DBT? Is it going to be Dagster? And we know what's kind of happened in the open source space here. I mean, bizarrely, Hive Metastore is the Metastore standard for like S3 and object storage, which is ridiculous because I mean, it's fine, but like it's really old now. And yeah, that's what everyone is using or some derivative of it. And so ideally, we don't end up in a similar position here where we end up with some really bad solution that just randomly took over the industry.
Tell us how you really feel, Matt. Sorry to all the Hive Metastore fans out there. Matt's drunk.
I think it was good when it came out, but it's not new anymore, right? It's been around for a bit.
I think there's people are working on this still, right? Yeah, but it is the standard, right? And hopefully it doesn't fall prey to the Lindy effect where it's just here to stay because it's here. So yeah, that's interesting. Yeah, I mean,
Hive Metastore is fine as long as you actually don't use Hive with it. Anything but Hive is
yeah.
I was talking to a friend about that the other day, actually. So it's like, we still do everything in Hive. And I'm like, I am so sorry for you, but anyway, it is what it is. Yeah, I mean, this is I think a theme that pops up on the show quite often is just interoperability. Like we talk about this a ton. I guess have there been any new revelations for you? You tend to think about this a lot more than I do. So,
that's a good question. So I think in the book we kind of talk about it as something data engineers need to think about. Well, we didn't really give any kind of definitive solution.
Well, there isn't one.
No, there isn't one. I think that the model versioning idea actually could be a lot more powerful, and we maybe need to give it a bit more credit. So I think the reason we didn't try to do model versioning in the past with traditional data warehouses is that they were extremely space constrained, right? You couldn't have multiple versions of a table. The problem we potentially have now is that this idea might work fine for small tables that aren't like CPU intensive and storage intensive. But once you get into tables where the computation to build those tables is really, really high, you don't want to have 3 versions floating around. It's just not practical. But I don't know if there's some middle ground where we could start doing some versioning where it's reasonable, and certain other tables you just have to do very aggressive cleanup.
That's a good question. I don't know.
I think keeping versions of tables is actually quite cheap. If you look at the warehouse pricing, like for example, Snowflake or Databricks, the price you pay for storage typically is a tiny fraction of what you pay for compute. And also they have the time history, right? So they kind of give this to you for free. So you pay for a terabyte of the table in the current version, but you can always access this table in the like 2 weeks ago state. But I think that the ultimate problem, or where we should solve this problem, kind of coming back to the Tristan's point, is probably not to version things in production and have kind of multiple parallel worlds running in prod, but rather make the process of making changes to the data stack more robust. Because I've come to believe that most data issues, most bugs that are there that affect the business and make us scramble to investigate and fix are introduced by people making changes, and in the broad sense, right, by people. And that can be anything from, let's say, a software engineer refactoring an event because the microservice that they own can no longer send a particular field because now it's part of a different microservice, and so they remove it. And now like 30% of your Airflow or DBT DAG is all red because it relies on it, right? Or, for example, us changing, analytics engineer changing definition of session because the new app flow in the mobile app now defines session in a different way. And obviously, if you change this, your entire calculation of growth accounting and active users all the way to financial reporting that your CFO looks at is completely different, right? Even though it may not break a schema, it changes the whole definition of also so many metrics. And the list goes on, right? Changing dashboards, changing DBT models and breaking dashboards, machine learning, having skewed data sets because we change how our dimensions work. So ultimately, it all comes down to change management. And the cool thing is, I believe that we don't actually need the strict data contracts to do change management more reliably. Ultimately, what we need is pretty much three things. One, we need to focus on improving the workflow. So make sure that whatever people are doing, they keep doing, but we introduce some checks so they don't, let the data stack on fire. I've done it multiple times because I didn't have those checks in my career as data engineer. I think the second thing, which is important, is we kind of sounds obvious, but we need to know what we ship. The problem is in the world of data engineering, we often we think we know what we ship, but we don't, because, well, data is complex. Dependencies are also very complex. So I shipped a DBT model yesterday. Tomorrow, 3 different people, one created a machine learning model of it, another one pulled it into a report for experimentation. And then 2 weeks later, there's a CEO dashboard depending on this model. And I didn't know about that, right? And I think the other problem is that the things are evolving really, really fast. We have to evolve those things fast because the business always pressures us to ship more. And so knowing what we ship means that whenever someone makes a change, they need to understand the full impact of this change, right? Understanding, okay, if I'm changing a DBT model, how does this affect the model itself? So let's say I change the definition of an active session. Do I still have the same number of rows in this table? Obvious question, but sometimes not, right? And is it expected or not? And do I still have the same number of sessions? Do I have still the same total session duration number? And if not, do I expect this to be like that or not, right? So understanding what I ship right now, but then also understanding what is going to be affected, right? So for example, if I change the definition of an active session, how this affects all the downstream tables that calculate things like, LTVs and active users and retention and growth metrics. Can I maybe run those tables and those metrics in staging, right? And see exactly what's going to happen. And then, well, can we take it to the extreme and maybe I can even dry run or run dashboards on this new change, right? All the way so that I can see, okay, if I make this change here, my new data platform is going to look like this, right? And then if you apply this concept and you package this in the pull request, because ultimately pull request is our ultimate gatekeeping device, right? It's where it's our last chance to basically stop bad things from happening, because the moment you press merge, things go into prod, right? And so if you have all this information in the pull request, then you can send it to your stakeholders, or even better, you can maybe have a system that in CI identifies the stakeholders using lineage and then tags them and says, hey, Joe, Gleb is modifying active sessions and you seem to watch this Looker dashboard, or you may be maintaining this Looker dashboard. Maybe you should have a look at this PR. And then Joe looks at this PR and then gives +1, and then we're all on the same page and there is no unexpected problems. And so that's what I mean by know what we ship. And again, This is very counterintuitive because we think we know it, but we actually don't. And I think the third principle is we have to automate this, right? So everything I talked for like last 3 minutes, if this doesn't happen for every single commit, every single PR, no matter how small, it's guaranteed to blow things up, because the things break not when we expect them to. They break when we ship just a tiny renaming, refactoring for consistency, kind of a very small hotfix on a Friday afternoon, right? And so the only way to really harden the whole process, the entire data platform, and not break things is by automating the process that would make sure people know what they're doing, make sure that everyone who's affected knows what's happening before it's promoted to production. And I don't think it's hard to do. Ultimately, again, in software, the concept of CI/CD has been there for a while. And even in data, right, tools like DBT make a lot of these components of this, what I'm talking about, available. For example, in DBT, you can build staging environments with one click, right? if you're using dbt cloud, it's even simpler. It kind of comes pre-baked with this, and then all we need is just layer all these checks on top in the CI process. And again, tools are so great these days. GitHub Actions is just YAML files.
Right.
So you just put your dbt tests, lineage, data diff, and then you have the full idea of what's going to happen in the pull request. So
is this
I think a lot
Datafold's
can be
going?
done way before we go into like versioning contract stage.
Sure. Is this your new pivot? Just kidding.
Well, that's what I've been doing for last 2 years.
Yeah.
It's just, I think that a lot of these ideas of like exactly how this workflow should look like have been maturing together with the data stack. Because 2 years ago, when we started building this, the idea of staging environment in data was very novel to people. Like, people developed in prod. You basically shipped something and you looked.
Oh yeah, that was your staging and dev and test. It was just
exactly.
Yeah.
Well,
So
and it's funny
your prod
because
was your
well, it's funny because it seems like old school enterprises were actually ahead on this. Like your old school data warehousing teams with ETL developers would use Stage, but the bleeding edge.
Well, and you could do all the checks. That's just it.
Yeah,
like
yeah.
all the stuff you just described. Like this was done like 20 plus years ago. I mean, but again, it also meant you bought multi-million-dollar systems that were very monolithic. And I think, and it's a good point. I mean, because again, you could click a button and say, okay, so how's this going to affect like everything downstream? Like that's. So I would say if you just open up one of those products and just look at how it worked and just reverse it, and you probably have. But I think your idea of basically everything is, Git and everything's sort of the first class citizen, same with CI. Like that's a big evolution. So everything is decentralized now, not monolithic. And so, but yeah, I mean, I've seen these systems work, and I really, I was like, that's cool. Why isn't that happening here in the modern data stack? And it certainly should, but, and we were talking earlier this morning. You brought up the idea of chaos engineering too. And maybe that's worth chatting about for a second. So.
Yeah. I mean, I'm familiar with this at Netflix. I don't know if they're still doing this, but they have this notion of like Chaos Monkey. And so Chaos Monkey will like randomly shut down microservices and cause things to fail. And the idea is that you are doing some testing in production, right? Like they have really robust CI/CD. But the idea is that you're constantly like kind of hammering your system just a bit.
The edge cases
to see how it responds. And maybe, I don't know, is there room for something like that in data too?
Well, I think there is definitely a room for catching edge cases by just double checking things. Whether it happens in prod or in staging, I think doesn't necessarily matter. In staging is better, again, because we're catching things earlier. I think that there is huge potential in doing things as simple as basic dry runs. So what is a dry run? We run some code on some, let's say, new code. We run some code without actually using data. So for example, we take a empty table, but we run the new logic that we just pushed, new SQL logic or new LookML logic or whatever. Why? Because it runs instantly, doesn't require any compute, and it catches a whole bunch of different errors from SQL syntax to schema mismatches. And I think that goes a long way. So one of the cool tools that handle that in a kind of like cross data stack layer environment is called Spectacles. So what they do is basically CI/CD checks for Looker. Because Looker, especially like large organizations, like at Lyft, we would have tens of thousands of lines of LookML code. And when you have that big of a project, things are going to break all the time, especially if the upstream layer, the transformation layer constantly evolves. And how do you not, how do you make sure things don't break without requiring people to just do, manual work that doesn't scale? So the idea is very simple. Every time you change something upstream, you can run Spectacles to dry run all the LookML on your new schemas, on your new code, and make sure that you at least don't have any kind of schema compatibility errors. And then I think that goes a long way. We can do this for other systems as well, for transformation layer, machine learning layer, because the idea of contract mismatches, the schema mismatches, is exactly what these types of errors would catch. And I think the other example of these kind of chaos monkey engineering is when we run assertions, right? So the idea of writing assertions with tools like DBT tests or great expectations, where you basically say, oh, this column should be always unique or never null, or one of these 4 values can be in the proper category column. These are great because they validate assumptions about your data, your business assumptions. But what these don't help is catch all the edge cases, like when data doesn't conform, or maybe when the data takes a slightly different shape, doesn't going to blow up your entire model or your entire DAG. And so what we can do is, for example, introduce certain random inputs. This is actually a very well explored concept in software engineering, and they use it a lot to test databases. Basically, they randomly create different data sets and random queries and execute thousands of those checks in the database to see when they have an exception, and then use this to actually harden the system and make it more robust. So we can use that when we do assertions and unit tests as well. That could help. But again, you don't need to do this in production. You can do this, the earlier you do this in the process, the more robust your system is, and the less you have to fix when it's already done the damage.
That's really interesting. And I think as well, pushing things upstream towards the application layer is something I think Matt and I have been talking a lot about too.
Especially with data mesh, it fits right in with that.
Well, especially data mesh, and then Snowflake has Unistore. Snowflake. So I mean, I'm very curious to see how this evolves. I think data is going to move up the stack towards the application layer even more than it already has, to the point where maybe a lot of these distinctions that we have with the quote modern data stack start becoming very blurred. Because I think ultimately a lot of these checks need to be done at the time the data is originating, and is being created. So we talk about the semantic layer a bit, and it's like that, in my opinion, should actually exist at the application layer. Maybe there's some sort of abstraction, some sort of interface, where as you're developing your application, your definitions, maybe it's in Python, who knows, but maybe an abstract method or something like that. But basically, the whole point is like it allows some sort of an interface where you can, as you're writing your classes, as you're writing your methods, defining metrics that are used at the app, that also transcribes down to the data layer as well. And so then at least you have some sort of point in time, definition of something. So where we see a lot of errors happen is that the software engineers sort of exist in a parallel universe to data, and data is always on the receiving end of things. And like, why is that? If data is that important and it's such a first-class citizen, why are we treated like a kind of a second-class citizen all the time? So
let me ask a question too. I mean, Lyft and Uber and these other companies have they have to treat data as part of the application, like not just application data, but analytics data. You're constantly doing analytics to decide when cars are going to arrive and this sort of thing. I mean, do they have better solutions for integration between application teams and real-time analytics teams?
Yeah, that's a good question.
Well, I think that the short answer, it's a very, very hard problem. And it's as much tooling problem as organizational problem, because software engineers, they may consume some analytics, but typically the types of things they care about immediately are more related to the actual service performance. Like, for example, if my service is defined to process ride requests, what I'm interested in, am I processing ride requests fast enough, correctly enough, without errors, without, for example, overusing my hardware that could lead to potential problems, right? So these are very operational metrics that they're immediately concerned in monitoring in real time. With very different tools, right? Tools like Grafana, Prometheus, etc. But then ultimately, software teams are incentivized in good all-around companies to actually care about some business metrics, right? Those business metrics are produced by analytics teams. So there is a relationship of, okay, we made this service, we improved this service. How does this move the needle on, for example, total number of rides Lyft delivers? But I think where it breaks is sort of in between of how does you go from, okay, my microservice sends certain events to like, oh, my team had the impact on this metric.
Bingo.
I think because software engineers typically don't or not working enough with data day to day, they lack the understanding of how it's used, and even the empathy for data engineers or for analytics engineers, right? They don't understand how this data is used and why, for example, if you send bad events, how painful it is to fix this, because you have now this supposedly mutable data, which is totally wrong in the warehouse. You have to clean this up, refire, backfill those events. It's really terrible. And so I think the way that we were able to solve this partially at Lyft is by introducing lineage. So if you have lineage, which basically is an idea of tracing dependencies across the entire data pipeline, from source data all the way to data applications through all the transformations, ideally in columnar level, right? Because if you have 30,000 tables, 1 million columns, doing it at table level is too coarse, right? Then we can, coming back to the hardening of the change management process, we can loop software engineers into the data world by, again, making them aware of the impacts of changes they're making on the application layer into the data layer. Simple example, again, I am mutating my event schema, right? Maybe removing event, removing a field, adding a field, or even not an event schema, even my transactional model that I use to store data for my microservice. And again, in CI, because those things are mature enough to detect, okay, if I am modifying a schema for my MySQL table, and we are copying this MySQL table to Snowflake and then doing analytics, I can detect whether this will have impact on anything in data, right, using lineage. And so if I know that and I can surface this in the CI in the pull request, I can bring this knowledge to the software engineer right at the point in time when they need to know that, right? So it all comes back to the sort of know what you ship, but extending it from, well, I know what I ship for my microservice to I know what I ship also for my data consumers downstream. I think and again, it's all doable. We have lineage systems today. Datafold provides one. We're not the only vendor doing that. Yeah. It all comes down to really willing to make this shift of sort of we ship data over the fence to, well, actually bring the teams together and let them collaborate. But again, you kind of blend processes and tools, right? That's why I'm saying pull request is so important, because it helps bring multiple teams together if you've surfaced the right information into that.
That's really interesting. What about embedding data engineers with software engineers?
Well, absolutely.
Yeah.
I mean, I think the idea of like having a centralized data engineering or data team in general is now becoming almost heretical, especially in the.
It's still very common, though. I think it's yeah.
Right, yeah.
I mean, a lot of it's Conway's law, though, right? So it's kind of like you're going to design systems according to how your teams are structured, and it's a classic case in point. I think a lot of data teams we see are like, it's the data team instead of like, it's the product team, and we have we happen to do data as well as software, right? Like that seems to be communication. Again, is just one of those things we talked about it yesterday too, or just this is like the main obstacle, I would say. And you can have a lot of great tools, but at the end of the day, if you ain't talking to each other, it kind of doesn't matter too much. So, and collaborating, right? So
yeah,
it's key.
100%. Yeah, I think embedded teams is, well, in the world where your data is evolving very, very fast, and you need it everywhere in your business, I think embedded model is the way to go for both data engineers, analytics engineers, data scientists. Yeah. But even in this model, you need to equip people with the right information for them to be able to collaborate. Otherwise, even if data engineers and software engineers are talking, you're relying on them being extremely diligent and, doing a lot of manual work to anticipate what they're doing, versus you can solve that last mile with tooling by providing that information.
Sure.
At a point where they're about to ship something.
And the software engineers have to have the incentive to really want to do more work than they already have.
Exactly.
So
ultimately, I think, it all comes down to, sort of shameless plug, but I think that the best feedback I got for Datafold, and Datafold is ultimately helping automate this proactive testing in the staging and in the dev process, is that Datafold, and that was from Truebill, from data engineering at Truebill. So they said that Datafold makes it easy for us to do the right thing. So ultimately, you want the tool to make it so easy to follow the process which prevents breakages that there's just no question of whether you want or not. It's just there, right? And you can't imagine your workflow without it. The moment you start relying on, people to be heroic and to test something for a week, things break, right? Because we can't afford testing something for a week. And so basically, you want to take something that would take 3 hours of testing and condense it, but you also want to take 0 hours of testing and then have something that catches errors.
You want to say something?
Just super tricky problems. I mean, I'm also kind of reminded both by what you were talking about, Gleb, and Tristan's comments about Google's concept of a monorepo. And it's been a few years since I've read one of these blog posts, so who knows, maybe they changed their practices. But the thing that horrifies software engineers about a monorepo is they're like, okay, in CI/CD, I commit one change and then the entire repo has to be tested. But that's not what Google does. I mean, they just have, and again, you alluded to this and Tristan did too, they just check dependencies and say, okay, these 3 other pieces of code are dependent on your piece of code. And you probably don't even know it because you don't know what you're shipping. You don't know who's consuming your code. But then you can just automatically test those 3 pieces. And if you pass, then your pull request goes in. And if you fail, then you need to contact those teams and find out what they're doing with your code and then try to fix it so it works on your next deploy. And same thing here, like data very much reminds me of that monorepo concept because you have this like sprawling just data across different storage systems, across different processing, especially in the cloud. You can have multiple different databases, but if you do have some way of monitoring that and just doing point testing where there is an issue, then we could potentially resolve these problems. So if we could somehow magically decide as an industry where that should live, in what layer that should live, is it going to be in data observability? Is it going to be in data quality tools? Is it going to be in orchestration? Then we would that would be amazing, but we'll see.
Totally. I think ultimately people should focus on what people should focus and spend their time on what they're good at, which is thinking, right? And then these kind of checks, dependency analysis, testing is what machines should be really doing as much as possible. And maybe it's fine if we don't agree on whether that lives in the observability layer or the transformation layer or the testing layer, as long as we agree on principles of where we're trying to get to. Maybe there are multiple ways to put this together, right? Maybe, well, you can get this kind of testing in dbt Cloud if you use dbt Cloud, but if you're using dbt Core or if you're using completely other framework, you can just put together this CI pipeline on your own by plugging different tools that would do these kind of checks for you, right? I think it's more of a kind of state of mind, right? That in software, they adopted, and I think it's widespread, but in data, it's still quite novel. And I think one of the misleading things or people, maybe naive things that we think as data practitioners is that we can still grasp the whole complexity of data in our heads. Like, well, I'm making change. I know what's going to happen because, well, I've worked on this pipeline for 3 years, right? I think it's time for us to actually acknowledge that, well, no, data is so complex that we just should not try to put it all in our heads. We should really offload it into tools and embrace automation. And again, software engineers are wise enough not to try this anymore on even simple code bases, right? Let alone a complex kind of microservice environments. And even I was actually quite surprised at what are the modern data stack levels of complexity. So at Lyft, at the times where we're using Hive, we have about 30,000 tables, but we're talking about a pre-IPO company with 200 person data team. Now, what we're seeing today in, let's say, Series A, B, C startups with smaller data teams, maybe 1 to 5 person data teams, it's not uncommon to have the same 30,000 tables in the warehouse and 1 million columns. So the complexity also kind of shifts left, right? You start, because infrastructure is so cheap and with dbt or Dagster, it's so easy to build new stuff. It just explodes, right? So we need to embrace automation much, much sooner in the workflow, or it will bite us consistently.
That's a really interesting point. I think, again, the thing we can say here is that data has already gotten much, much less complicated, right? Which is why a 1 to 5 person data team can even hope to manage 30,000 tables. This was not possible before really good managed open source and managed cloud data warehouses. And so Joe and I are actually reviewing a book for Andy Petrella right now about data observability. And that's kind of one of his big ideas too, is that if you have these tools, it's like the next step in automation, right? You can go way beyond where we are right now. So.
Yep, for sure.
kind of rounding things out, switching gears, what are your thoughts on where the data industry goes in the next few years?
Oh, wow. I think there are a few things happening that at least you can observe with almost naked eye, and I won't claim that I'll have like a unique insight. I think one of them is that, to Matt's point, putting together a data stack is far less complex today, far more affordable, which is great. And that means that we'll see probably orders of magnitude, many more data teams emerge everywhere in the world. So something that was only accessible to a well-founded tech startup in Silicon Valley 3-5 years ago now will be available to early stage startup anywhere in the world, or even not a startup, even a brick and mortar business selling ice cream. And I think it's great because ultimately, I think data has huge potential to improve the world in so many ways, right? Improving the businesses, how businesses are run, improving solving technical and scientific and other problems. So I think that's one. So we have many more data teams, probably, and the vast majority of them will want to operate at a huge scale of hundreds of people or very large data volumes, but they will likely have still the same problems. I think the other related sort of problem is that although data stacks become simpler to the end user, data will be more complex. I think we shifted. No one talks about big data anymore, right? Because, well, okay, big data, who cares if I can write a SQL query and it takes 3 seconds to process, right? But the complexity matters. It matters if I have 30,000 tables, because even though I can write a SQL query, well, which table do I query? That's a new kind of problem. You were talking about big metadata now. And that's a problem I think we haven't cracked. And I think that how do we work in this complexity effectively, both in terms of just being able to ship things, but also ship them consistently and having confidence and great reliability is a new challenge. And I think what will differentiate data teams, the great ones from, average or good ones, is how well they cope with this complexity. Probably, we can talk about also other tools and solutions, but I think these are the kind of macro things that I observe that will probably also define what happens in the tooling space and what happens in how we think about the whole profession.
Makes sense. And it's still early days in this field too. Like it feels like we're just getting started. So
yeah, for sure.
Yeah, that's awesome. Cool. Well, thanks for being on the show. For people who want to learn more about you or Datafold, how would they do that?
You can find me on Twitter. I'm at glebm, also at datafold.com. And I'm gleb@datafold.com if you want to reach out over email, whatever works.
You have a newsletter too, right?
Yeah, we have a newsletter called Folding Data.
Cool. Good name. So.
Thank you.
Yeah, awesome. Well, cool. Hope you have a good weekend. Thanks to the audience as well. Monday, we have Patrick McFadden from DataStax on. So that'll be really fun. Then I don't think we're doing a Friday show because I'm actually going to be on a road trip. So
yeah, you need a vacation anyways.
Well, yeah, happens. Oh, and by the way, if you haven't got your copy of Fundamentals of Data Engineering,
you're going to have to keep waiting apparently.
Yeah,
of Amazon.
Yeah. So Amazon apparently, when they get the books, they spend the next few weeks doing whatever Amazon does. I joke it's probably like seances and rituals with the book to get it ready for shipping. But anyway, supposedly it'll be shipping next week. But if you haven't gotten it, don't yell at me. Go email Andy Jassy about that. So, but yeah, cool. Gleb, thanks for being on the show.
Thanks so much, Joe and Matt.
Yeah, thanks. Great discussion.
Have a great time.
Yeah, thanks.
This was fun. Thank you.
Take care, man.